Let's look at two more graphing examples, but again, instead of us having to find the information about f prime and f double prime, they're going to give us the information. So they're going to give us the sign chart, they're going to give us some information about the domain and limits, and they're going to give us some points. And we just need to put the graph together, which of course can be a little bit tricky. So the first thing we're going to do is we're actually going to plot these points. All right, so I'm going to go right here, and I'm going to plot the points right here. So I'm going to have 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 1, 2. So I'm going to have negative 4, 0, negative 2, negative 2, 0, 0, 2, negative 2, and 4, 0. Okay, the next thing I'm going to do is I'm going to look at these limits they're giving me. So I look here and I can see that the limit they give me is the limit as x goes to positive or negative infinity. So that is the limit of a horizontal asymptote. Because remember, when x is going to positive or negative infinity, that's horizontal. So because I'm going to rewrite it, the limit as x goes to positive and negative infinity of f of x is equal to 2. This number is the horizontal asymptote. So I have a horizontal asymptote at y is equal to 2. Again, just to repeat, I knew that it was a horizontal because it's going to plus or minus. And because it's going to plus and minus, it's going to be the left and the right of the graph is going to go to y is equal to 2. So I'm going to do that in red. Next, I'm going to look at the graph, the charts. So my first derivative is first I'm decreasing, then I'm increasing, then I'm decreasing, and then I'm increasing. If I look at my domain, which is given to me at the beginning, it says all real numbers, which means that every one of my partition numbers is a critical number. So it can be an extrema. So because I'm going from decrease to increase, I'm going to do this in red. Negative 2 is going to be a max. Oh, I'm sorry, a min. At 0, because I go from increase to decrease, that's going to be a max. And then at 2, it's going to be a min. Now, it's also important to look at it, whether the derivative is 0 or undefined, not defined, ND, because remember, that's going to be the difference between a horizontal tangent line and a vertical tangent line. So because it's 0 at negative 2 and 2, I'm going to have a horizontal tangent line at both negative 2 and 2. And at 0, I'm going to have a vertical tangent line. So we're going to see what that looks like. So I'm going to write at negative 2 and 2. I'm going to actually put right now that it's a max and a min. So at negative 2, it's a min. It looks like a min. At 0, it's a max. And at 2, it's a min. Okay, next I'm going to look at my second derivative. So first I'm concave down, and then I'm concave up, and then I'm concave up, and then I'm concave down. Now again, because the domain is all real numbers, any one of these partition numbers can be an inflection point as long as the concavity changes. And the concavity changes at negative 4 and at 4. But it doesn't change at 0, so it's not an inflection point. So at negative 4 and 4, I'm going to write inflection point and inflection point. So now I'm going to look at how I begin. So I take a look and I'm beginning, my beginning part is decreasing and concave down. And then if I labeled my graph correctly, I will know when to change. I also need to take into consideration my horizontal tangent line. It affects both the left and the right side of the graph. So I'm decreasing concave down. This line here is going to continue and get really close to the horizontal asymptote, but it's never going to touch it, so it's going to get closer and closer to the horizontal asymptote. So I get to my inflection point, I change concavity to concave up, I hit my minimum, I U-turn, I hit my max, but what I need to be careful here is that I have a vertical tangent line. So I stay concave up, I hit a little tusk, I hit my minimum, I U-turn, I go to my inflection point, I change to concave up, and then I follow my horizontal tangent line. So once again, I'm beginning by decreasing concave down. I go along my horizontal asymptote on the left. I change concavity. I hit my min, I U-turn. I hit my max, I U-turn, but as a vertical tangent line. So the difference is I'm doing this instead of this. So this would be a horizontal and this would be a vertical. So at 0, I need to do the vertical one. Then I hit my min, I U-turn, I hit my inflection point, and I change concavity and I follow my horizontal asymptote. Let's do one more. Okay, so this one is all real numbers except x is equal to -2, which means that -2 cannot be a critical number or an inflection point. So here I'm giving a lot more limits. So first limit I'm going to look at is the last one, because that's going to be the horizontal one, asymptote. I'm told that the limit as x goes to infinity of f of x is equal to 1. So this number is the horizontal asymptote. So y equals 1. But the key here is that it's only affecting the positive infinity, which means that it's only going to affect the right side of the graph. So we're going to do that. Let's plot some points here. I need to go up to at least 3. So 1, 2, 3, 4. 1, 2, 3, 4. Then I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so let me plot my points. -4, 0, 0, 0, 4, 3, 6, 2. And then I have a horizontal asymptote, but only affecting the right side of the graph. So at y equals 1, I'm only going to do it for the right, the positive infinity side. The difference is on the last one is that it gave us plus and minus infinity. So it was both the right and left side of the graph. Okay, if we take a look at the other limits, the answers of the limits, I'm going to do it in green, is infinity. And when the limit is equal to infinity, it's a vertical asymptote. So you have the vertical asymptote, you're giving two limits. -2 from the left is going to go up, and -2 from the right is going to go down. But remember that the actual asymptote, the vertical asymptote, is what x is approaching. This is the vertical asymptote. So I have one vertical asymptote, and it's at -2. It's just that from the left, it's going to shoot up, and from the right, it's going to shoot down. So let's do that in red. I have it at -2. Perfect. Here we go. And now we can go on to our charts, and let's see if we have any max, mins. So I'm increasing, then I'm increasing, and then I'm decreasing. At -2, the first derivative is not defined because the domain originally -2 was not included, and it's a vertical asymptote. So I only have one extrema. My extrema is at 4. This is a max because I'm increasing and then decreasing. So I'm going to write max at 4. It looks like a max. Then for my second derivative, I am concave up, and then I'm concave down, and then I'm concave up. Now, yes, the concavity changes at -2, but it's not part of the domain, so it can't be an inflection point. So my only inflection point is at 6. So let's see how I begin. I begin by increasing and concave up, and I need to go on the left side, shoot up on my vertical asymptote. So I'm increasing, concave up, and then I shoot up from the left side of my vertical asymptote. On the right side of my vertical asymptote, I am increasing but concave down. Okay, so if I highlight that here in yellow, I am increasing but concave down on the right side of my vertical asymptote. So I'm increasing, concave down. I go to my max, I U-turn, I hit my inflection point, I change concavity, and I follow along my horizontal asymptote. And on the right, I have to follow along my horizontal asymptote one more time because it's x going to positive infinity. So the horizontal asymptote is only affecting the right side of the graph.